So in this video, we're going to rewrite quadratic functions into different forms. And remember, the three forms of a quadratic function that we've learned in this class are standard form, which is when we just have everything multiplied out, so y equals ax squared plus bx plus c. And then we have vertex form, which has the general form of y equals a parenthesis x opposite h squared plus k. And then finally we have intercept form, which looks like y equals a x opposite p and x opposite q, where p and q stand for your intercept. So we have standard form, vertex form, and intercept form, and we're going to flip-flop between these three in this video. So here we're going to rewrite standard form into vertex form. So our goal is to end up something like y equals a x minus h quantity squared plus k. So our goal is to end up where we can pull the vertex out of the equation. And when I look here, I notice that we have something in parentheses with x squared. So automatically my brain starts thinking about the completing the square method, because in that method, that was when we created something that looked like that. So you should make a note here that in order to rewrite something from standard form into vertex form, we're going to use the completing the square method. So that's the best way to do that from standard form into vertex form. So if I'm going to use completing the square here, I'm going to focus here on these terms that contain an x. And I know that inside of my parentheses here, I want x to have a coefficient of 1. So I'm going to start here by factoring out that 2, or undistributing the 2. So I have y equals 2, and then in the parentheses I have x squared minus 16x, and then I have a plus 8 here on the outside. So I know my goal is to end up with something that looks like 2, and then in parentheses I would have x plus or minus some number squared, and then that plus 8 would be on the outside. So I got to figure out what number is in here being added or subtracted with x. Now remember, for completing the square, we focused in on this piece right here, and we figured out what was missing in order to make that a perfect squared trinomial. So if I think about this for a second, remember a is always 1. Our b value there is always whatever our number is times 2. And our c value is always whatever our number is squared. So I can see that my b value here is a negative 16. So if I take negative 16 and I divide that by 2, I know that my number here inside of parentheses with x is a negative 8, because negative 16 divided by 2 is a negative 8. Then if I take that negative 8 and I square it, I'm going to find my missing c value. So I know that I need to add 64 inside of here. Now, remember, if we're going to add 64 inside of there, I also have to add 64 times this a value out here of 2 to the left-hand side of the equation. So here we really have y plus 64 times 2 is 128. So that's really what I have. But this looks better, and this looks closer to vertex form. Now from here, the last thing I need to do is get y by itself. So we subtract 128 from each side. So we end up with y equals 2 times x minus 8 quantity squared minus 120. So in order to rewrite something from standard form into vertex form, we're going to use the completing the square method. So in this video, we're going to rewrite something from standard form into intercept form. And when I think about intercept form, I think about the fact that this is in the form of y equals a x minus p x minus q. And what I notice here is that this does not look like completing the square. There's no quantity squared here. But what I do notice is this looks a lot like when I applied the zero product property, which I was using when I was factoring. So in order to rewrite something from standard form into intercept form, we need to use our factoring strategies. And we have two factoring strategies that we've studied so far this year. One of them is when we factor out the greatest common factor, which isn't going to be helpful here because the greatest common factor we have for these three items is 1. Or we can use the ABC method for factoring trinomials. So we're going to use the ABC method here because that's going to help us factor out this trinomial. So if I start with ABC, I have A is 4, B is -5, and C is -6. So I need two numbers that multiply to A times C, which is a -24, and add to B, which is a -5. So I need two numbers that multiply to -24, add to -5, and when I think through those, I come up with -8 and 3. So now I'm going to rewrite this middle term using the -8 and 3. So I have y equals 4x squared minus 8x plus 3x minus 6. So now I look at these in pairs, and here I have a greatest common factor of 4x. So this would be y equals 4x, and then it's x minus 2. And then here we have a greatest common factor of 3. So I have x minus 2 there as well. So I can group those together, and I get 4x plus 3 and x minus 2. Now, what's tricky here is I can't really just leave this as is because it's not exactly intercept form. These all have x values with a coefficient of 1. So we're going to need to get a little bit strategic here. What we're going to have to do is we're going to have to rewrite this one right here. This one is all set with a coefficient of 1, but that first one is not. I noticed that the x value has a coefficient of 4. So what we have to do here is we actually have to factor out that 4. So this becomes 1x. Now, what's tricky here is 3 is not divisible by 4. So when we factor out 4, we're really dividing 3 by 4. So this is going to become plus 3/4. And then we leave that other part as is. So notice that I factored out a 4 to make this x value have a coefficient of 1. So my final intercept form is y equals 4x plus 3/4 and then x minus 2. And here I can clearly see what my x-intercepts would be since it's written in intercept form with those x values having a coefficient of 1. So in this example here, we're going to rewrite vertex form into standard form. So standard form, remember, is y equals ax squared plus bx plus c. So really what we're going to have to do here is we're going to have to multiply this out. And we're going to have to multiply this out by utilizing the order of operations. So order of operations, we start with the parenthesis, and we have to deal with the squared. So we're going to first multiply out x minus 4 quantity squared. So if we do x times x and x times 4, I end up with x squared minus 4x. Then I do minus 4 times x and times -4. So we get minus 4x plus 16. And then I combined the like terms that I see together in there. So I get x squared minus 8x plus 16. So now I've multiplied that piece out, but you got to remember we still have the 3 out in front here, as well as the -10 on the outside. So we started by performing the square. Then we need to do the multiplication here between the 3 and the parentheses, so we distribute. So we end up with y equals 3x squared minus 24x plus 48. And then that minus 10 is still on the outside. And then here we combined like terms that we see. So I see 48 and -10. So we end up with y equals 3x squared minus 24x plus 38. So in this fourth example, we're going to rewrite intercept form into standard form, which again is y equals ax squared plus bx plus c. So we're going to start by multiplying everything out because we need no parentheses in order for it to be in standard form. And I tend to focus on these parenthesis pieces first. We can multiply by that -4 last. So let's multiply x minus 5 times x minus 3. So we distribute the x first, so we get x squared minus 3x, and then we distribute that -5, so we get minus 5x plus 15. We then combine together any like terms that we see, so we have x squared minus 8x plus 15. And then don't forget that was all inside of parentheses because we have a -4 out here that we still need to multiply everything by. So we start by multiplying out the parentheses, and then we end by distributing that -4. So we end up with y equals -4x squared plus 32x minus 60. So just to recap here, if we want to go from standard form into vertex form, we're going to use completing the square. If we go from standard form into intercept form, we're going to use our knowledge of factoring. If we go from vertex form to standard form, we're simply going to multiply everything out and combine like terms. And if we go from intercept form into standard form, again, we're going to multiply everything out and combine like terms.